Good afternoon, all of you. Good afternoon. I got good afternoon messages in chat. Good afternoon, Smith. Good afternoon, all of you, beta. So, have it. Do anybody remember what we did in the last class? Can you share what we did in the last class, beta? Yes, all of you. Please, you can write up in chat what we did in the last class. Beta, I'm waiting for your answers so that we can start from that point where we have left. What, according to you, we discussed in the last class? Yes, all of you. You can post up in chat, beta. Yes, all of you, beta, please respond what we did in the last class. Am I audible to you? Yes, am I audible, beta? Okay, now I start getting answers. Weight, bias, activation, fine. Yes, Yan, what we did in the last class. Can you summarize what we did? There were certain values or parameters we need to tune up to get the desired output. Then we learned about what is training, what is learning, right? There are different working methodologies in the neural network, right? So there is one mathematical model associated with it. We perform weighted sum of the inputs and then we apply the activation function to get the desired output. Fine, these were the things we discussed. Now with this lecture we'll be making a particular mathematical model for the neural network, like that is developed by the researchers. There are certain different models which are having certain working mathematics behind them. They'll be helpful in calculating the value of output of a neuron. When one neuron is given to you and inputs are applied, how you are going to calculate the outputs is according to the mathematical model. So as you can see up on this slide, we have McCulloch-Pitts model. For today's discussion, we'll be taking up McCulloch and Pitts model. Okay, Sian, there is some network issue. You just try to understand the things. Otherwise, I'll help you wherever you feel difficulty. Fine, beta. So just try to understand the things. Whenever there is a confusion, you can ask up. Okay, beta. So we will be discussing majorly about this model, how this model is used to design different kind of problems, how this model is practically being used in different set of application. This is what we'll be going to discuss. So going upon, we'll be making up what is Macaulay-Spitz of new model, then determining the output of neuron in different scenarios, like different set of inputs is yielding different kind of outputs. So we'll be finding out the outputs, then modeling basic logic gates through MP neuron. This is like the objectives of this particular presentation. If it will not be completed by today, we'll be continuing with Monday's lecture. Will no problem. The only thing is you also, because there are certain numerical problems inside this presentation, you will be trying side by side and then letting me know the solutions. Fine. Firstly, you will understand what is being required. Then you will make up the things, whatever I'll ask you, you will tell me the answers, then we'll complete the numerical problem. Fine. So there are three basic models being used, but like the basic mathematical models where the neurons are configured. The first one, the very first one, and the basic is McCulloch and Pitts model, which we are going to discuss today. Next is Hab model, that is for self-organized learning, that will be doing in the later units, unit 2 or 3. And then we have Rosenblatt perceptron model that we'll be doing in the subsequent lectures. Fine. So these are the three major models or the major breakthroughs which have mathematically modeled the neurons. Fine. Now going on up, this is one model which copies the similarities of that biological neuron that we have developed. Like, okay, so all of you can like reply through chat. What are different portions of your biological neuron we have taken care of for design of artificial neural network? What different portions of biological neuron we have copied to develop the artificial neuron? Yes, you can answer through chat, beta. the different parts of biological neuron we have used to design our artificial neuron. Your biological neuron is a very complex structure. What portions out of that we have used to make our own artificial neuron? We have done this mapping. Okay, as I got one answer, dendritus. Yes, next. Axons. Nilesh said dendritus. Synapses. Because there's a certain spelling mistake. Ayusha, axon. Ayusha, it's axon. Synapses and dendritus, fine. Okay, so I got certain kind of answers. Synapse, axon, dendritus, fine. So these were the parts of and soma, that is cell body, the nucleus. Fine. So major four portions we have taken up: axon, dendritus, then we have synapse, and then cell body, that is the soma, the nucleus. Fine. So we have developed a common, like a generic model, like we have different set of inputs. Then we apply to a summation node where all the things are sum up and bias is being applied. And then the whole summation is passed on to the activation function. Then we have generated the output. Now, MP neuron, MP model is a specific case of that particular model. You will see the calculations are same. The activation function for MP neuron is binary. Activation function in MP neuron is binary. What it means, it can give us only two possible outputs, like either low or high. So depending upon the logic you have used, either it can be 0 or 1, or it can be -1 or 1, right? So basically we always prefer binary to be 0 and 1. So the activation function in MP neuron is binary, and the inputs also. The inputs to this MP neuron are binary. Fine. This is the most important point to be noted about this MP model. The inputs and outputs of this model are binary. It will work upon binary inputs and present us with binary outputs. Fine. So MP neurons are connected by directed weighted paths, as we have seen with the generic model also. All the inputs are connected with weighted paths, and the further neuron to neuron connection is through weighted path. Each neuron has a fixed threshold. If the net input to the neuron is greater than threshold, neuron fires. We will see up this thing, like how we are going to compare with the threshold. We have done the similar things also. So basically this is combined two broad research domains, the threshold logic and the artificial neurons developed. So it just applied the activation function in the form of threshold function. So what major points to be noted here? The inputs and outputs are binary. Both the inputs and outputs are binary. Secondly, the activation function in the MP neuron is threshold function. Did you understand what is threshold function? We have discussed this also. Yes, anybody who can tell me what is threshold function or threshold logic? Yes, anybody? Those who want to speak up, they can raise their hand. I can promote you to be a presenter. You can turn on your mic and speak up. You need to answer me what is a threshold logic as per you. Yes, all of you, I'm waiting for your answers. What is threshold logic? Yes, I've got no answer from Angad. Like from the previous sessions, I'm noting who all are responding and who are not responding. Angad, Anuj, I've not got any answer from you. Ashish, Ayusha answered today, so I can minimum activation function. No, it's meet. Ma'am, if the value is greater than threshold, then it will be 1, and if it is less than, yes, Nilesh, it's right. And if it is, then it will be 0. Fine. So threshold is a kind. Okay, just let me point out a few persons who are not responding first, because I'm noticing like many of you haven't even replied once on my queries. Yes, Kartike. Then because I like personally know you all, so I remember your names and who are responding. I'm noticing. I keep on noticing the things. Fine. Pratiksha. Beta, I didn't get responses from you. Then Seville, Yamini, Twinkle, no major responses from you. Even Suraj, I expect the responses from you, but you are not, you are like on a comfort zone to not respond. Beta, please be responsive so that I can know whether you are understanding or not. It is not to point out some persons, it is just to make you arouse that you have to respond. Only then I can work upon like you are understanding or not, right? So what is the like fun of taking doubts along with you after the lecture? So just be attentive and clear it side by side in the lecture itself. Fine. So the names I have taken up, it's not that they are like to be fined or something. I'm just trying to find out all of you because I know you all. You are like the responsive persons, and you just take part in the interactions. So please be respond. Okay, so I expect the answers from all of you, the whom I have pointed out. So this is all about the basic MP model. So what we have taken up, the input is binary, the output is binary. Fine. The activation function in the neuron, in the MP neuron, is taken as a threshold function. So how threshold function works, as Nilesh written in the chat, if the any input to the threshold is greater than the value of t, there is certain set value of threshold. If the value is greater than t, we take the output equal to 1. If value is less than t, we take the output equal to 0. So that is why we can say that because of application of this threshold logic, our neuron works as a binary output device. Fine. So it is providing us binary output because we have put up condition. Input आपकी चाहे 10 आए, 50 आए, 60 आए, any input can be there. Once it is compared with threshold, output can either be 1 or 0. Is it fine till this point? Yes, beta, is it fine till this point? Did you understand what is threshold logic? Okay, I got the answer from Twinkle. Ajit, Ajit, I have not pointed out to you, but you were also there in the list. Thank you, all of you. Okay, so just let me go a bit further. Okay, all of you, Manisha, Krishna, Pratiksha, thank you, all of you, Ashish. So all of you are now awake somewhere. Fine, fine, fine. Anuj, okay. So whosoever I have pointed out, now you will have to answer through certain questions. This is all yes, no. So now I'll be working upon giving you certain kind of thing to be solved. Then I'll be expecting answers from you. Fine. So just let me go a bit further. So the important things to be noted up here is the weights are termed as excitatory or inhibitory. The weights connecting the two layers of the neuron or input to the node, they will, all the weights will be defined using two terminologies. One is excitatory and another is inhibitory. All the positive weights or the weights which are greater than 0 will be treated as excitatory, and all the negative weights or the weights less than 0 will be taken as inhibitory. Fine. Another important thing about MP neuron is, while designing MP neuron, all excitatory weights need to be of same value. All excitatory weights need to be of same value, and all inhibitory weights need to be of same value. We will understand this thing if I am connecting 4 inputs and all weights I am taking positive, all weights will be equal. If I am taking weight value equal to 1, so it will be for all the neurons, all the inputs. Fine, we'll be doing through the example also. But you must remember, all the positive weights are known as excitatory weights. The negative weights are known as inhibitory weights. And in a particular neuron, all excitatory weights must be of same value and all inhibitory weights must be of same value. These are the conditions to be fulfilled for designing an MP neuron. Fine. So there is another terminology is being used. If the output of that neuron is 1, that means neuron is activated or neuron is fired. Otherwise, neuron is non-active. Is it clear? Okay. So let me go further. Now just answer me this thing. I'll be launching up a poll for you. You'll have to choose between these two things. Yes, all of you. Either they will be termed as excitatory or inhibitory. All of you go through this poll and answer. Quick responses. "24" with no response. Be quick, bitter. 16. So just Shubham Kumar, no response. Suraj, no response. 14 are still left for the responses. Anurag, Dipankar, Kartikeya. So all of you, beta, please respond to the things so that I can see whether you are understanding the most crisp basics or not. Because this is one thing which is like to be kept in mind while designing the things. Muskan, Puneet. So 10 students have not responded. Sanjeev and Satyam. Okay, I'm stopping up this poll. And just let me tell you, because the weight values are negative, so they will be termed as inhibitory. So we'll be going with choice number B. Because weights are negative, they'll be they'll be named as inhibitory. If the weights are positive, it will be treated as excitatory. Fine. So going on. So now see up this diagram. So the things I told you, that all the inhibitory weights and all the excitatory weights need to be same. So let me tell you, I'll zoom out for this. So you can see this diagram. The weights for the upper two segments is W. W, that is, we have taken the positive weight value as W, and negative weight value we have taken as minus P. So you can see there all the positive weights are W and all the negative weights are minus P. So all the excitatory weights are same and all the inhibitory weights are same. Fine. So this is the requirement of your MP neuron. We need to take up excitatory weights are same and inhibitory weights are same. Okay. So just let me go further. So we will now be seeing how we can define or like design different types of logic gates by using this MP neuron model. You must all are aware of different that logic gates. Fine, we'll be using that knowledge to develop the thing. So we know the kind of output required and we are available with input. We have to tune the value of weight and threshold to get the desired output. And you can add up bias if you want, but in between the examples I'm not taking bias for time being. You can take if your particular problem is getting better with the inclusion of bias. Fine. So the tuning parameters I'll be considering will be weight values and the threshold. I'll be setting up the threshold and weight in such a way so that I can get my desired output. Tuning I required by why? Because I want to map to the desired output. Fine. So just let me go further. So this is all what we have discussed, like net is equal to the terminology now I'm going to use here will be net. This net is the output after your summation node, including your bias and weighted sum of input. This bias plus weighted sum of input is equal to net. Then applying the net activation function to the net will give you the final output. Fine. So this is the representation I am going to use. These are the inputs x1, x2, w1, w2 are the weights. They are passed to the summation node. This upper arrow is representing bias. The bias is added, and through the threshold we are getting the desired output. Fine. So is it clear till this point? Yes, all of you? Is it clear with this diagram? Any? Okay, so I'll be using this diagram for reference. This will be my basic reference diagram I'll be using to design my MP neuron. Fine. So the input terminology I'll be using as X. Weight terminology I'll be using as W. Activation function will be a threshold function. That is why a square wave kind of thing is drawn here. And then there is output. Fine. So we'll proceed with the designing. Just let me check if there is any doubt from anyone in the chat. Okay, fine. So just going further. So this is what we've discussed through. Just check this condition now. If your this net is greater than equal to threshold, output is 1. If your net, that is y in, is less than threshold, output is 0. We will be considering this case. If y in is greater than equal to threshold, output is 1. If y in is less than threshold, output is equal to 0. Fine. So going now, just see this thing very carefully. This is, we are going to design a single input MP neuron with bias is equal to 0 and weight is equal to -1. Weight is equal to -1. So can you see how net is calculated? Okay, just show me, let me show you the calculations. So I'm going up here. So since it was having single input, so I'll be taking as X. Muskan, is it to all? Like, am I audible to you all? As Muskan has said me that Muskan, it may be like some problem on your end, beta. So please check. Thank you, beta. Thank all of you. Saurabh, Ashish. So I'm just now making up. Here I have net. Actually, thank you. Y. So then I have, since my input is single, I have single input X, and the weight given in the question was -1 and bias is equal to 0. Okay, I'll be using that. I'm writing on the side so that you can remember. Weight is equal to -1 and bias is equal to 0. This is given in the statement. Weight is equal to -1 and bias is equal to 0. So with this, X is having two possible combinations, 0 and X can be, we can have with single input, there will be two possible combinations. Kshitij, is it audible now? Because the things were reloading on my end. I pressed a certain button mistakenly. Okay, beta. Okay, thank you. So the net will be calculated according to net is equal to Wx plus B. That is, we are going to multiply weight into input, then adding up the bias. Now, since we have single input, so it will be Wx. Otherwise, if we'll be having more inputs, we'll be considering W1, X1 plus W2, X2, and so on and so forth. So just let me know what is the value of net coming up here in the first scenario where X is equal to 0. When X is equal to 0, what is net coming up? Yes, all of you solve it and tell me. Net, the formula we are going to use is W into X plus B. So let me show you one example. So this will be equivalent to W here is given as -1 multiply by X input is 0 plus bias is also 0. Fine. So since 0 is multiplied by -1, the resultant will be, the net here I am getting is 0. Okay. For the next case, Yes, all of you kindly solve. Now input is 1. 1 multiply. Now this will lead to yes 1 multiply by weight is -1, bias is 0. So I'll get up here. So what value I'm getting here? This is -1. I'm getting here -1. Is it clear till this point? Yes, all of you are solving. That's fine. So I consider it as clear. Now, my question says that I want to make a single neuron and say I want to make it as a NOT gate. Say I want to make it a NOT gate. I want to make it a NOT gate. Then accordingly, what output I want? For NOT gate, what is my desired output? Yes, anyone? For NOT gate, what is my desired output? For NOT gate, what is the scenario I required? 1 0. Yes. If input is 0, output is 1. If input is 1, output is 0. This is my desired output. Now, what can be the value of threshold so that I can get y is equal to 1 0? Inverted output, Ayusha, fine. Pratiksha, complement of output, fine. So, what can be the value of threshold? This is now major question to be treated up. What threshold you are going to set up? Can anybody tell me what threshold I can set up? The condition I follow is if net is less than threshold, my output is equal to 0, and if net is greater than equal to threshold, my output is equal to 1. This equation I am following. So anybody who can tell me what threshold I can set up? I want the output to be 1 in case my input is 0, and input, if it is 1, output need to be 0, because that is I am designing a NOT gate. So what threshold value I can set for this scenario? Yes, what can be the threshold? I need to satisfy these two conditions. My conditions I need to satisfy are these two conditions. My net, if less than threshold, output is 0. Net greater than equal to threshold, output is equal to 1. So, okay, Nilesh, I got your value, that is minus 0.5. Okay, just wait for other answers also. Then we will test with this. What can be the value of threshold to satisfy this condition? I want y to be 1 in first case. Y 1 kab hoga? Y will be 1 when net is greater than threshold. So now here net is 0. Net is 0. This 0 will be greater than certain negative value. 0 will be greater than certain negative value, then only it will be 1. 0 सबसे छोटा है positives में. Fine. So if according to Nilesh I take my net, I have taken net is equal to yes minus 0.5. Did it satisfy the condition? Yes. Kindly all of you verify. We can change the weight and bias. Yes, it beta. This time we are not going to change because we have picked the statement as it is. The design problem was specifying the condition. If it is not as per the design problem, if it is given as like we have to take up from you can say if it is directly straightforward that you have to design NOT gate, then you can pick up any value of weight and bias. This can also work with the threshold is equal to 0. Yes, all of you, do it work with threshold is equal to 0? Check with this condition. If I take threshold is equal to 0, here it is, it was threshold. Now if I take threshold is equal to 0, yes Nilesh, test with 0, you have taken as minus 0.5, whether it will be working with 0 also. See here, the condition says greater than equal to, greater than equal to. Now, this 0 is equal to threshold. 0 is equal to threshold. That is my net is equal to threshold. That means I got y equal to 1. Now, here net is minus 1. This minus 1 is less than 0. That is my threshold. This is threshold. I compare it with my net. net is less than threshold, so I get my output equal to 0. Now my this y maps to the desired output. So is this design problem clear to you? Yes, all of you? Is there any kind of doubt in this? Beta, see, choice of threshold, choice of weights, these are the parameters which are independent to you, choice of bias also. But as far as if it is given in the question itself, if it is given in the design statement that you have to take weight is equal to this and bias is equal to this, then you will have to go with that. Okay, sir? We can change. These are the tunable parameters. This is the designer problem that we'll have to go with choice of weights and we'll have to select the optimum values. Fine. But as far as if it is written in the statements itself, then we are going to follow that only. Okay. So all of you just try one another thing I am giving you. Say I have now, I will drop certain thing for you. This is the truth table. I am taking up the same NOT gate. We'll be completing that. Okay, just let me draw it once for you. So here I'm taking as input X, then I will take here as net, and here I'm taking as Y. Fine. So the problem statement says you that weight is equal to 2 and bias is equal to 3. You have to design a NOT gate. You have to design a NOT gate. You will have to tell me the values of threshold. You will be telling me the value of threshold in this case what you have taken. So X will be 0 and 1. You will be telling me the values of net according to this weight and bias value. Y need to be 1 and 0. Just tell me the values of net and threshold. Just tell me net. So all of you just try up this and let me know. Weight here is now 2 and bias is equal to 3. I'm again writing the formula of your net value. Net is equal to W multiply X plus B. So use that formula and find out net. Nilesh, now B is also there. Bias is given as 3, weight is equal to 2. Find out the value of net. Yes, Yamini, net is equal to, I've got the answers. Net is equal to 3 in the first case. And in the second case, 2 into 1 plus 3. Yes, 5. So what can be the bias here now? Sorry, threshold. Okay, all of you have done it. Okay, so what will be the threshold? My threshold must satisfy that if this term is greater than threshold, then output is 1. And this term is less than threshold, output is 0. Is there any threshold existing of this kind? Avinash, thank you. Samiksha 3-5 isme theek hai. Okay, so just let me know, is there any T existing? 3 is greater than T and 5 is less than T. Is there any T existing? There is no T existing in this particular case. Fine. So you will have to reiterate the weight value and the bias. Because with this set of weight and bias, with this weight and bias, designing of NOT is not possible. Fine. So as a designer, we will update what updations we will be looking for. Weight and bias. So just let us try that we are just varying the bias. Then what can be the changes? If I am now taking weight, I am just taking same as equal to 2 and bias I am reducing to 1. So how it can change now? Maybe not change the condition for threshold. Say, and you can change the threshold. You can change any of the 3 parameters. Thus the requirement is you must match the desired output. right? So it's all your choice whether you want to vary the weight, whether you want to vary the bias, or you want to vary the threshold. If we take threshold is equal to 4 in this particular case, so 3 will not be greater than 4, no? So it will fail up, because we want that for the very first case our output need to be 1. It will only give us value 1 when this net is greater than t. Fine. So just try to solve this with alternative value of weight, bias and threshold, and let me know what you have taken. All of you try it and just let me know what values you have taken, what weight you have taken, what bias you have taken, and what threshold you have taken to get not get working from this neuron. Yes, all of you? Like t greater than net is equal to 1, t less than net. No, beta, it is reverse. Sen, it is reverse. You take it as net greater than t, it is equal to 1, and net less than t, we can make it to 0. Okay, so we'll be using this condition throughout. So better not to change the condition and work upon the working of the changing in the values of weight, bias, and then threshold. So all of you, I'm waiting for your responses, like what weight you have taken, what bias you have taken, and what threshold you have taken to design the NOT gate. So I'll be waiting for the values from your end. So you are going to tell me the updated values, what you have got. Yes, all of you, I'm waiting. Fine, just let me know what you have got as the value of weight, bias, and threshold to design a NOT gate using a single neuron. So I'm on side by side, I'm drawing a blank table for you so that in that case, bias value should be greater than weight. It can be, Sen, it can be. Only condition with the bias is the input to bias is logic 1. So I'm drawing a blank table side by side until the time you people are solving, and then I'll be getting things from you, like what is weight you have selected, what is the bias you have selected, and what is the threshold you have selected. Okay, I got an answer from Nilesh. Nilesh, I'll be testing in a while. Just let me complete the table. X, then we have here net, and there we have Y. Again, I want X to be 0 here and 1 here, and the output need to be 1 for first case and 0 for second case. So I got answer firstly from Nilesh. Let us try. Nilesh have given me answer weight is equal to -2 comma bias is equal to 0 and threshold is equal to 1. This is I got from Nilesh. Threshold is greater. Nilesh, threshold need to be an absolute value. Like it can be 0 or 1. It cannot be greater than equal to kind of thing. So I am taking the threshold from your answer as threshold is equal to 0. And we can apply the condition as net greater than equal to threshold, but threshold will be one absolute value. So if I take this case, all of you solve like the Nilesh given me the example. If it is -2, so the net here will be -2 multiply 0 plus 0. So I'm getting here. So I'm taking different colors for different all students. So it will be 0 here. So let me take this is I'm solving for Nilesh value. Since bias is 0, weight is -2. So here is 0 and here I'm getting -2. Fine. And threshold according to Nilesh is 0. So this 0 is equal to 0. So 1 I've got. This is fine. And for this case, -2 is less than 0. I've got 0. Fine. So another value I've got from Ayusha. Ayusha have given me value -1 and bias equal to 1 and threshold equal to 1. So accordingly, let me check. This will be -1 multiply 0 plus 1. So I get 1 here. And this will be weight multiply input -1 plus 1. So I'm getting 0 here. Fine. So threshold she have taken as 1. So this 1 is greater than equal to 1, fine. 0 is less than 1. Are you sure your answer is also correct? Nilesh, your is also correct. Yes, I'm waiting for all others' answers. Yes, beta, because in that way you can develop the logics that how to tune up the parameters if you do it by your hand. So I'm waiting for your answers, then I'll be putting up in truth table. Okay, I've got from Yamini. Weight is equal to 2, bias is equal to 1, threshold equal to 2. So let us take weight is equal to 2. Firstly, weight is equal to 2, so 2 into 0 plus 1. So I'm getting 1 here, and then I have again 2 plus 1. So I have 3 here. So Yamini have set threshold equal to 2. So Yamini, I'm not getting whether you are doing it correctly or not, but I don't think your threshold will work upon. Since your net value is 1 and 3. So this 1, if you take threshold equal to 2, this 1 is less than 2. So output is 0. Fine. This 3 is greater than 2, output is 1. Yamini, I'm solving for your values. So this will fail up because we require output to be 1 and 0. Fine. So you must tune. Rudraksh, I'm waiting for your response. Weight is equal to 2, weight is equal to 1. Okay, Yamini, did you understand where is the problem? If you are choosing 2 as a threshold, that will reverse your required output. Fine, so you need to take up the things in that way. Okay, Twinkle, I got weight value as 2 from your side. What is the bias you are taking and threshold? Weight equal to 2. Fine, bias equal to 1. So let me solve for you. Now this purple color is for Twinkle. I'm taking 2 as weight. So very first value will come up 1. And second value will be 2 plus 1, that is 3. So again this one, no beta Twinkle, this will also not work. This will not work. So all of you just keep on trying and just try to find out the optimum value. I got right answers from Nilesh and Ayusha. Their logic was working. I'm waiting for others also. So you can see you are making your network learn. You are providing certain weights and then checking the output. Since it is not matching with the desired, then you are reiterating the weights. So this process is known as learning of a neuron. Fine, you are making your neuron learn. जो आप बार बार weight initialize कर रहे हैं, you are testing different weights. That is, you are making your neuron learn. Fine. So I'm waiting for answers from others also, beta. Yes, all of you just try to solve it. I've got right answers from Nilesh, Ayusha. Rudraksh, your values are incomplete. W is equal to 2, W is equal to 1. What you are trying to convey, I'm not getting. Yamini, have you tried to update the value, beta? Okay, Rudraksh, I'm waiting for your responses, all of you. Because if I put up a truth table directly in the slide, that will end up your mind. Then you will be fixed with that values, and that is you will be cramming and you'll be designing not get as it is throughout your syllabus. But I don't want that thing because you have to develop the logics yourself. I can show you the way, you have to develop the logics then, because your logical mind need to be work upon these situations. Fine. So in a minute we'll be ending up and we'll be continuing with this with the next lecture also. Fine. So if any doubt is there to anyone, he or she can ask up. All others can leave the session. Like, I'm waiting for the doubts, the sincere doubts. While designing, if you faced any doubt, you can ask up. Say, and I'll test your condition. W is equal to n. But I have to give certain value, a particular value. Say I have taken n is equal to 1. And I have to go with that. A numerical value I need to define up. Okay. So if I take weight is equal to 1, ma'am, any value would work other than 0 in place of n. Okay, we'll try with this on Monday's class. Fine. So you just keep this thing noted with you that weight is equal to n. Even I am copying for me so that we can test upon it later on. Okay, Yamini will test with the next class. Fine. All of you, please leave because you have your next session also. Yes, those who are left, please leave. Avinash, Kunal, Rahul, Shubham.